A reminder that all these notes are on the website. You can print them off, so if you're having difficulty reading as I go through these examples, please remember to print off the notes, and then it may be a little easier for you to follow. Introduction to age word problems. The structure of these word problems is consistent. The first sentence will provide information about what names to write down, as well as an algebraic relationship between those names. The second sentence will be broken down into two parts. At the beginning of the second sentence will be what we call an introductory phrase, such as 5 years ago. This will be used to create a second column where each of the preceding algebraic expressions are changed by either adding or subtracting the indicated amount. For 5 years ago, that would imply that each algebraic expression needs to be subtracted by 5. Everything after the introductory phrase in the second sentence will be translated into an equation. That equation will be solved, and that will get us back into the first column. Example of specifically what I'm saying. You're going to look at the first sentence. From the first sentence, you should be able to describe the characters, the names of the people. So you should extract names. And you should also be able to set up an algebraic expression for each person. In the second sentence, it's going to be split into two parts. It'll have an introductory phrase such as 5 years ago, 3 years from now, 1 year from now, whatever the case may be. That is going to allow you to create a second column and change the expressions you wrote from the first sentence. So you're going to get an introductory clause that will in effect allow you to change your expressions. And the rest of that sentence will set up an equation for that specific moment in time. So if I say 10 years ago, such and such, that equation that I write is going to be only valid for 10 years ago. The unique thing about these problems, though, is once you solve them, you will solve for a variable found in your first column. And so it'll bring you back to the present tense. And that's what these examples are trying to show you. So after the introductory clause, you're looking for an equation set in time. And that equation must use the expressions set from the second column. Example, we've got this problem right here. I'm going to try and zoom this in a little bit, see if it's a little easier to see then. It says, Larry is 15 years older than Beth. Well, here I've got two names. That's the first sentence. From the first sentence, I'm able to extract names, and I'm able to write expressions for each of the persons or the people. And so I'm going to write Larry and Beth. And it says Larry is 15 years older than Beth. So if I call Beth B, one of our tricks is whoever is mentioned last should be where you start. So Beth was mentioned last, I must call her B for Beth. And if Larry is 15 years older, I think we can figure out if Larry is 15 years older than Beth, an expression for Larry could be B plus 15. And we check for the logicalness of our expression or reasonability of our expression. If Larry is 15 years older, we can call him B plus 15 versus Beth being B. As we move to the second sentence, it says, in 4 years. That introductory clause allows me to change these expressions appropriately. In 4 years means I want to add 4 to each of those expressions. So I can call Larry B plus 19 and Beth B plus 4 as I added 4 to each of those preceding expressions. And then what's left is an equation. It says Larry will be 1 year older than twice Beth's age. Larry will be 1 year older than twice Beth's age. So my broken English, I can say Larry will be, future tense of the word is, which means equals, 1 more, so I shift over, put a +1, then twice Beth. So I go 2 times Beth. Now I go from the second column of expressions. I have to use these expressions over here as I try to plug them in here and solve the algebra. So I'm going to say b plus 19 is equal to 2 times b plus 4 plus 1. As I solve this, I must distribute. So I'll say b plus 19 is equal to 2b plus 8 plus 1. Combining my like terms. See, the algebra here is not very difficult. I can move this b to the right, and I can move this 9 to the left. This becomes 19 minus 9 equals 2b minus b. So 10 is equal to b. And then I answer the questions. The question says find the age of each today. If I want to know the age of each today, that means that Beth is 10 years old today, and Larry must be 25. And of course, we've got the box to put our answers in. So once again, first sentence allowed me to create the first column of expressions. Second sentence was broken into 2 parts. It gave me a second column with the introductory phrase, and it gave me my equation. Once I solve the equation will put me back into present tense, and I'm able to answer the ages of each today just by plugging in that solution to the equation. B was 10, so Beth was 10. B was 10, so Larry was 25. First example of age word problems.